Okay, this video tutorial looks at the mathematical strand of data representation and interpretation, and more specifically we're going to look at standard deviation. So what is standard deviation? So standard deviation is basically a more accurate method of determining the spread of the data. So previously we would have looked at things like range or IQR, alright, to talk about the spread of the data. However, these only take into account two data values in their calculations. Alright, so the range being the biggest take the smallest, and the IQR being Q3 take Q1. However, standard deviation is basically a measure of how far each of the set of data deviates from the mean of the data, and it's a lot more accurate at working out the consistency. So how do we calculate standard deviation? Well, let's consider the data set that we've got in front of us, all right, which is 2, 3, 5, 9, 11. All right, the mean of the data is 6, okay, because if we add them all up and divide by 5, we end up with a mean data of 6. And so what we're trying to do here is then we need to find out how far each actual number, so we've got 2, 3, 5, 9, and 11, how far they actually deviate from the average or from the mean. Now we can say that 2 is actually 4 away from 6. Okay, so it's minus 4. So if we go 2 take 6, we get minus 4. 3 take 6 gives us minus 3. 5 take 6 gives us minus 1. 9 take 6 gives us 3, and 11 take 6 gives us 5. That's how we work out this part here, which is our value take away the mean. All right. Now what we need to do in order to work out standard deviation is we take that value, okay, and we square it, and then we add up our sums. So add up all the numbers that we've got. All right, so we take all of those values, we square them all, we add them all up. When we've added them up, okay, it gives us a total of 60. We divide by 5, all right, because that's the amount of numbers that we've had. We actually had a set of 5 data. That gives us an answer of 12. Once we've got that 12, since we squared all the deviations to start with, we actually have to take the square root of this value to convert it back to its original units. That is why we end up squaring 12 here. Okay. Now this whole process is given by a formula. Standard deviation is the square root of the sum of the values, take away the mean, all squared, divided by the number of values. Okay. Now obviously the closer the data values, so the closer our x values are to the actual mean of our data, the smaller the standard deviation will be, which means the more accurate or the more consistent our data will be. So let's have a look at an example. All right, we've got two players, or two basketball players in this particular case, Michael and Troy, and they both like shooting three-point shots because that's the funnest part. Over the last 6 games, they've scored the following three-point shots. So Michael in red, he's got a 4, 6, 6, 5, 4, and 5 three-point shots that he's scored. Troy, on the other hand, has got 4, 2, 7, 8, 3, and 4 in his last 6. All right. Now we can work out the averages of each player by adding up the numbers and then dividing by 6, and Michael gets an average of 5, and Troy gets an average of 4.66 or 4.67 rounded. All right. So we can say that Michael's average is slightly higher than Troy's average of 3s per game. But if we're going to comment on the standard deviation, we need to be able to figure out our numbers. All right, so here we've got, and I'll use orange, we've got our values for both players. All right, so Michael was 466,545. Troy was 427,834. Now, in the next column, we've actually had to work out how far those values are from the mean. So here we can say, well, we've got 4 take away 5 gives us minus 1. We've then got 6 take 5 gives us 1. Again, 6 take 5 gives, and you can see we're taking away the mean to get our values. All right, so that's what we do for Michael. Obviously, the mean for Troy is 4.67. So we would have to take away 4.67 from our data values. Basically, we've then ended up squaring our answers. So in our next column, we've had to square the difference between them. And then we've added the total to get to here. So Michael had a total of 4. 1, 2, 3, 4. So 1 plus 1 plus 1 plus 1 gives me a total of 4. Troy, when we add all these up, we end up with this. All right. And then remember that the standard deviation is given by the square root of our total divided by our number. All right. And that's going to give us this. Troy's would be the square root of 27.34 over 5. Would give us this. So we can say, looking at our standard deviations, Michael's standard deviation of 0.9 basically is a lot smaller than Troy's standard deviation of 2.33, saying that even though they have a very similar average, Michael's probably the more consistent shooter. Okay, so here's a practice question I'd like you to have a go at. It's very similar to the Michael and Troy 3-point shooting competition, but here we have two greengrocers a greengrocer purchasing oranges from two different wholesalers. So basically you need to find the mean and the standard deviation for each data set, and then just compare them to decide which one you think is best. Please feel free to pause the video. Once you think you've got the correct answers, continue the video and we'll see how you went. Okay, so let's see how you went. We've got the question up the top. We need to find the mean and the standard deviation. All right, so obviously with Sunblessed, we've added up all our totals divided by 5, and we've got a total mean of 10. For Valencia Star, we've done the same thing, and we've ended up with a mean of 11. So you could say that Sunblessed has less on average blemishes, which is great. So they're probably leading at the moment. However, when we go through and we look at the difference between the values and the mean, all right, so we're now looking at our second column of each, you can see that Valencia Star has smaller numbers here, okay, or a smaller difference. All right, so then when we square them in our third column, all right, you can see that the total for Valencia Star is actually a lot less, which therefore correlates to a much smaller standard deviation for Valencia Star. Okay, so they're more consistent, all right, even though on average they have one more blemish, they're actually more consistent with their oranges. So I'm hoping that you were able to come to that conclusion.